Black holes are among the most exotic objects in the universe. They represent finality and inescapability. They are the remnants of once giant stars, and they are a cosmic drain in the centers of galaxies. Black holes are celestial bodies so dense, their gravity so strong, that nothing can escape their pull. The idea of black holes is generally attributed to the French mathematician Pierre-Simon Laplace, who, in 1796, was studying the subject of escape velocity. This is the speed something must be accelerated to in order to prevent being pulled back by the gravity of a larger body. For example, to escape the Earth's gravitational pull, we must accelerate our rockets to over 11 kilometers per second. Any slower and they would fall back to Earth, victim of the pull of Earth's gravity. Any faster and it will never return.
While working on this problem, Laplace noticed a relationship between the size of an object and its mass. He noticed that if you made an object smaller, but kept its mass the same, the escape velocity increased. So while playing with the calculations, he found that if you made the Earth half as small, and with its mass the same, the escape velocity doubled to 22 kilometers per second. Taking things further, he reasoned that if you kept squeezing the Earth smaller and smaller, eventually the escape velocity would equal the speed of light. For the Earth to be this heavy, Laplace calculated it would be only 1.8 millimeters across. The idea of the black hole was born.
Over 100 years later, the publication of Einstein's general theory of relativity in 1915 brought the prediction that gravity could bend light rays. A German mathematician-astronomer named Karl Schwarzschild took that notion and worked out that for an object of any given mass, there was a specific radius at which light would be unable to escape. This distance has become known as the Schwarzschild radius, and the formula he came up with defines the size any object of mass m would need to be in order for its escape velocity to equal the speed of light.
The concept of black holes remained a theoretical construct for decades. Astronomers had no real use for them because, at the time, the universe was considered relatively simple. Stars collected in galaxies and perhaps untold billions of planets collected around the stars. No one considered black holes possible in nature.
All that changed in 1962 with the launch of an Aerobee rocket with X-ray detectors on board. Designed to look for X-rays from the moon, the detector found not only a faint background glow of X-rays from all over the sky, there was also one strong source of X-ray emission in the constellation of Scorpius. Known as Scorpius X1, it was the first X-ray source ever detected.
Astronomers hadn't anticipated this. Creating X-rays requires an enormous amount of energy and an extremely hot gas. For a source that was as many light years away as Scorpius X1 was, to have the quantity of X-ray emissions that was detected implied that it must be generating huge quantities of X-rays. The simplest way this could happen is if material was heated to extreme temperatures by being accelerated by gravity onto a nearby object. For this to be true, the companion object had to be very small and very dense. The era of high-energy astrophysics was born.
The next pivotal discovery came with the launch of the Uhuru X-ray satellite on December 12, 1970. Given the job of mapping the X-ray sky, this satellite found 339 sources. Some were galaxies, some supernova remnants, but most were X-ray binary stars. Here, ordinary stars streamed their material onto nearby neutron stars, which gets extremely hot as it falls, emitting X-rays. One of these sources, however, a source known as Cygnus X1, did not fall into this category. Neutron stars are formed from the collapse of stars less than 3 times the mass of the Sun. From Uhuru data, the companion to this star appeared to be 5 to 8 times the mass of the Sun. This object was too large to be a neutron star. Current, more recent estimates put the mass of this companion at least 10 solar masses. This could be nothing other than a black hole. After hundreds of years of theory and speculation, black holes have moved into the realm of observation. Their discovery was as unexpected as it was strange. Luckily for us, the truth of the universe isn't limited by our feeble ability to understand it.